Welcome guys to the video. This is video 2 out of 3 when it comes to trig. So our first lesson was over just trig, so finding the sides. This lesson will be over inverse trig, and then we'll have a third lesson when I see you next. Before we get started, let's first review and remember trig before we get into inverse. Now if you're looking at this, it should look familiar. These are actually the first several problems from the homework that you hopefully have finished by now. So what we're going to do is we're going to use the special right triangles to find our trig ratios. The reason why we're using those is because we already know the measures of those triangles, those sides. So I have here a 30-60 triangle, and then I have down here a 45-45 triangle. So I'm going to write my equations, and these are the equations from the tic-tac-toe board or from the very first line in the equations chart. So I have n, and n root 2. And then up here I have n root 3, and then 2n. Okay? All I did was label my triangle according to the tic-tac-toe chart or that very first line in the equations. Now I'm going to come over here and I'm going to find the trig functions of these angles. So if I want sine of 30, I'm looking over here, and remember our SOHCAHTOA. Alright, sine is opposite over hypotenuse. So I'm actually going to label my triangle right now so we can see what we're doing. This is the opposite of the angle, this is adjacent to the angle, and the hypotenuse is always the same. So sine would be opposite over hypotenuse. So in this case, sine of 30 would be n over 2n. Then you simplify and you get the sine of 30 is equal to 1/2. Okay? Cosine of 60 would be the same thing, only now we're over here in the 60 angle. So I'm going to relabel my triangle. This is opposite of my 60 angle, adjacent, and the hypotenuse stays the same. So when we're looking for the cosine of 60, what we get is n over 2n, which again turns into 1/2. Notice the pattern? Sometimes the sine and the cosine of different angles gives you the exact same number. This is a pattern that we recognized or should have recognized in the last lesson as well. Alright, next let's move on to our 45-45. Now because the isosceles triangle of the 45-45-90 has two of the same angles, it doesn't really matter which one we pick. I'm going to use this one because why not? So again, sine is opposite over hypotenuse. So that means I'm going to have n over n root 2. Simplify. And I have this. However, I can't have a radical in my denominator. So I'm going to rationalize. And now I have root 2 over 2. Okay. Tangent of 45. I'm going to use the exact same angle. This is my opposite, this is my adjacent. I am left with n over n, which gives me 1. Okay? So if you were looking at the homework of last night and you didn't understand what you should have been doing, you're supposed to use your special right triangles to solve. Now these patterns and these triangles come back in pre-cal. Alright, we use these triangles a lot in pre-cal, so the reason why we're starting this now is that you can build up to it and you can see it more easily when you get there. But for now, let's just continue with our lesson. Again, this is inverse trigonometry. Now, the difference between normal trig and inverse trig, as I will call it. Normal trig finds the side lengths. Okay, maybe you noticed, but in all of your homework you were looking for the side lengths. Inverse trig finds the angles. Okay, so we are looking for the angle lengths in this PowerPoint. Let's get started. So when you're using inverse trig, you're going to be using different symbols. If you remember, when we were solving and doing practice problems yesterday, we had a problem that said sine of, I think it was 44, is equal to 12 over x. Okay, you had to solve for x, so we needed to multiply both sides by x, and we had a situation like this. Okay, and I told you that when you're doing this, you have to divide by the whole thing. You have to divide sine of 44 away, and then you divide it on both sides. Okay? The reason I said this, that you divide everything together, is that division does not separate the angle from the trig function. Okay, when we divided, no matter how hard you divide, you won't separate the trig function, sine, from the angle of 44. Okay? Just like any operation, you have to do the reverse of the operation to handle that. So if I have two numbers that are multiplied by each other, I need to divide to separate them. Okay? Well, the reverse of trig is inverse trig. And that's where we get these symbols over here. Okay? Now, the way the inverse trig ratios work is in our normal trig functions, we have the angle over here. So we have sine of theta is equal to x. Okay, well, the inverse function flips those. So I flip theta and I flip x. So now I have the inverse of the side is equal to the angle. Okay, and that's how this is going to work. You're going to get things set up, and then you're going to take the inverse of the side fraction, the side ratio, and that'll give you your angle. Now these symbols right here, sine -1, cosine -1 to the power -1, tangent to -1. These are all inverse. So this is the inverse of sine, inverse of cosine, inverse of tangent. The other way you'll see these on some calculators, depending on what you're using, is arc. Sometimes you'll see arc sine or arc cosine. Or arc tangent. So depending on the calculator that you're using, you may see sine with a -1, or you may see arc sine. Okay, you just got to look for that. So let's solve some problems. Now, here we have our two problems, and we have the sine, the trig function is equal to our trig ratio. That's how you need to have things set up. You need to have your trig function is equal to the ratio. Because then what you're going to do is you're just going to flip it. So now I have sine, the inverse of sine of my sides is equal to x. Okay, this is my calculator ready answer, and then I could plug this into the calculator to solve. Now some reminders. When you plug into the calculator, first, okay, so calculator reminders. That's not how you spell that word. The first reminder is make sure that your calculator is in degrees. All right, must be in degree mode. Okay, if it's not in degree mode, you're going to get negative numbers, odd decimals. It's just not going to work out. All right, there's two videos posted to the other assignment that should tell you how to do that, but it has to be in degree mode. Second, you need to make sure you have this inverse trig. If you're not using inverse trig, you also won't get the right thing. Okay. Now the third thing is make sure you know how to use your calculator. Different calculators will have different methods of how you plug in the trig. So in class we can go over those. But for right now, please make sure you know how to use your calculator. All right, so what I'm going to do is I am going to plug my calculator ready answer into my calculator. So I use the inverse of sine, then I plug in my fraction exactly as I see it. So that is the square root of 2 divided by 2. And you should get that x is equal to 45. If you didn't get x is equal to 45, that probably either means you weren't in degree mode or you had some sort of calculator error. Next, let's go on to cosine. So in order to figure out my angle, I'm going to take the inverse. So now I have the inverse of cosine of 1/2 is equal to x. So I'm going to plug this into my calculator using the inverse mode. A common question here as I'm plugging into my calculator is, can I use decimals? And my answer to that is, as much as you can, use fractions. There's already too many decimals floating around. We don't need to add more. And your answer should be 60, which, if you go back and check the warm-up, we actually do a problem, cosine of 60 equals, and we end up with 1/2. So that's a good way to check some of these basic problems. Now for some more advanced problems. Okay? Now, inverse trig follows the exact same logic as normal trig, meaning, that should be an angle symbol, that the trig function you use is dependent on the information given. So we're still following the SOHCAHTOA. Alright, this has not gone away. And just now we're looking for the angles, not the sides. So if I need to find angle A is over here. So theta is right here. And I have the opposite and my adjacent. Opposite and adjacent. So I'll be using tangent. So the tangent of theta is equal to opposite 6 over 20. Now it's always good practice to reduce your fraction before you get started on anything else. So 60 over 20 simplifies down to the tangent of theta is equal to 3 over 10. Now I'm solving for theta, I'm not solving for my sides, so now I'm going to take the inverse of tangent of 3 over 10 and set it equal to theta. This is my calculator ready, so if on the test or quiz I say no calculators, I want this to be your answer. This is my calculator ready answer, and I'm going to plug this into the calculator. The inverse tangent of 3 divided by 10. And you should have gotten that theta is equal to 16.7. Okay? Now, when we're rounding, okay, the original answer that I see in my calculator is that theta is equal to 16.6992. When you're solving the problems, when you're working problems, because there may be multiple step problems, you want to leave all decimals out to the 4th place. Okay? Throughout the entire problem, leave your decimals in the 4th place. The reason for this, if you round too soon, you end up getting numbers that are way off. Okay? So always leave your numbers in the 4th decimal place until you're ready to box the answer and turn it in. When you're ready to box the answer as an answer, you round to the 100th place. Now in this one, it ends up rounding so that we get 16.7, but if this number had not been a 9, you would have left it as 16.69. Alright, last problem of the day. So we're going to use x and y, and you may use your calculator, so hopefully you've been following along this whole time. Now, in order to use trig or inverse trig, you have to have 2 pieces of information. You either need 2 sides or you need an angle and a side. And of course, it goes without saying that it should be a right triangle. So right now, when I'm looking at x and y, if I'm trying to solve for x, I would currently need another side, which I don't have. If I'm going to solve for y, well, I have an 8 and a y. I would need an angle, which I also don't have. So immediately, I don't have all the information that I need. So now I have to solve for those pieces. Since this triangle over here is a right triangle, I'm going to solve for this angle over here. So that's 90 minus 43 is equal to 47. Okay? Which means that this angle over here is also 43. So now I'm in this triangle right here, and in this triangle I do have an angle and a side in 8, so I'm going to use normal trig in order to solve for y. So in this one, keep using SOHCAHTOA. I have my opposite and my hypotenuse. So that means I'm going to be using sine. The sine of 43 is equal to 8 over y. Now since I have my angle, I'm going to just keep using sine. I'm not going to use inverse. I'm just going to solve for y. So multiply y to both sides. Divide sine of 43 to both sides. This is my calculator ready answer that I'm going to plug in the calculator. If you're following along on your calculator, you should have gotten 11.7302. Okay, remember, take all work out to the fourth decimal place while we're still solving the problem. So y is equal to 11.7302. Now I need to solve for my x. There's a few ways I could do this. One way is using the big triangle, but that looks like more work than I need. So what I'm going to do is I'm going to solve for this side right here. The reason why I'm going to solve for the share side is once I have the shared side, I then have enough information to solve for x in this triangle. Okay, so solving for my share side, I can either do tangent or I can do cosine. It doesn't matter, I have enough information. But I'm going to use tangent, that way I don't have to use my decimal. So I'm going to go tangent, so this is opposite over adjacent. Tangent of 43 is equal to 8 over z. I solve for z, and you should get this. This is your calculator ready answer. 8 divided by the tangent of 43. When you plug it into the calculator, you should get that z is equal to 8.5789. Okay, again, take out to the fourth decimal place. Now, as I compare my answer to my picture, this kind of makes sense. All right, these two triangles, all three of these triangles, are not quite isosceles. So 45, 45 would have been an isosceles triangle, but the angle is pretty close. So it makes sense that my side lengths should also be pretty close in measure. All right, so that means that my shared side is 8.5789. Now for solving for x, I have enough information. I have an angle and two sides. I can go ahead and solve. Now you can use either the angle of 47 or the angle of 43. I'm going to use the angle of 43, but you should come out to the same answer either way. So since I'm using 43, this is the opposite side, and this is my adjacent side. So I'm going to be using tangent again. Tangent of 43 is equal to 8.5789 over x. Solve for x, and this is your calculator ready answer. Once you plug this into the calculator, you should get that x is equal to 9.1997, or something very, very similar. So now I've solved for all my pieces. I am ready to turn in my answers. I'm looking for x and for y, and so now I'm going to round to the second decimal place. So x is equal to 9.2, and y is equal to 11.73. All right, this is the end of the PowerPoint. In class, we'll go over a few more problems on inverse trig, but I will see you next time. If you have any questions, please make sure you mark them and ask them when I see you.